For nearly 2,000 years, the consensus held that reality was split into two strict zones. At the center sat the Earth, a place of constant change and decay. Surrounding it were the crystalline spheres, the heavens, a realm believed to be divine, eternal, and immune to alteration. Right at the boundary of that celestial realm sits the moon. Ancient philosophers argued it was made of a fifth element called ether. Unlike the dirt we walk on, ether was considered mathematically flawless, a perfectly smooth material without a single bump or blemish. While anyone could see dark patches on the lunar surface, Aristotelian scholars dismissed them as variations in density or reflections of the Earth's oceans. No one considered them to be physical, rocky terrain. This wasn't just an astronomical theory, it was the theological and physical foundation of the world. Challenging the perfection of the moon meant questioning the entire structure of reality. In 1609, news spread of a Dutch invention called a perspective glass. It was a tube fitted with lenses that made distant objects appear closer, for surveying land. Galileo Galilei built his own version in Venice, refining the optics through trial and error. While the original Dutch tools magnified objects 3 times, Galileo soon increased his instrument's power to 20 and eventually 30 times. Then he made a subversive choice. He took this military tool and aimed it at the night sky. By redirecting a lens from the horizon to the heavens, he collected the physical evidence that would dismantle the most established scientific theory in history. Galileo began a systematic scan of the moon in late 1609. Because the telescope had a very narrow field of view, he had to build a mental map of the surface incrementally over many nights. He focused his attention on the lunar terminator, the dividing line separating the sunlit day side from the dark night side. If the moon were a perfect sphere, this line would be a smooth curve. But here, the terminator is jagged and broken. Deep in the dark side, Galileo saw isolated bright points that slowly grew until they merged with the illuminated lunar disk. These observations created a crisis for the established worldview. The physical data directly contradicted the philosophical mandate that celestial bodies must be smooth and perfect. These are Galileo's published woodcuts from Sidereus Nuncius. His training in chiaroscuro allowed him to interpret these light patches as 3-dimensional shadows rather than flat stains. He compared these patterns to an earthly sunrise. Tall peaks catch the sun's rays, while valleys remain in darkness. This geometric model calculates height using the moon's radius, sunlight grazing the terminator, and a sunlit peak. Applying the Pythagorean theorem, Galileo combined the lunar radius with the peak's distance from the terminator, revealing these lunar mountains reached 4 miles high. The resulting geometry proved a truly devastating point. The moon is not a perfect sphere of ether, but a rugged, rocky world. The heavens are made of the same physical material as Earth. Galileo published these findings in March 1610 in a pamphlet called Sidereus Nuncius, or the Starry Messenger. It was a direct attempt to provide visual proof to the public. The academic establishment scrambled to respond. A philosopher named Ludovico delle Colombe tried to save Aristotle's physics with a new speculative theory. He conceded the telescope showed mountains, but argued they were encased within a perfectly smooth crystalline sphere, its valleys filled with transparent material. Galileo mocked this, arguing that theories relying on invisible, unobservable entities are built for metaphysical convenience, not scientific truth. This exchange established physical observation as the primary standard for evidence, superseding authority of ancient texts. Galileo's geometric proof dismantled the cosmological system that had dictated human thought for 2,000 years. By insisting that measurable evidence must triumph over ancient authority, he helped establish the core tenets of the modern scientific method. The telescope revealed a tangible, rocky frontier where philosophers had previously seen only pristine clockwork. If you want to continue exploring the physical universe, hit subscribe for more videos.